Hi everyone. So the question is uni-valued binary tree, and the question says that a binary tree is uni-valued if every node in this tree has the same value. So we are given the root of a binary tree and we have to return true if every node in the tree has the same value. Otherwise, we have to return false. So in this example, with all the nodes as 1, we are going to return true. And in this example, we are going to return false because there's a node with value 5 which does not match the root value 2. And yeah. So one thing to note here is, let's say, you were just visiting a family and then you had a grandfather who was wearing a red t-shirt. Now you actually had to go to his children and see if everyone is wearing a red t-shirt. If anyone just wore another color, you just had to return false. So we're going to solve this using BFS. We could have solved this using DFS as well, but right now we are going to solve this using BFS. So the pseudocode of it is like we have to store the root's value and we have to check every value with the root value. If the value do not match, we have to immediately return false. And when the queue is empty, we know that we have processed every node and then everyone just wore the same color of t-shirt. Or let's say we had a uni-valued binary tree. So then we return a true. So I'm going to copy paste just a skeleton for BFS. So yeah, I've copy pasted this. So this is BFS skeleton, by the way. So after my after my queue is empty, we just return true because there was nothing as every element has the same value. Now we are going to actually store the value for root. So let's store that integer. It's int, right? Yeah. So my int root val is, or why do we need to store this? We already have a reference to the root. So let's not store. So right now we have to see if root dot val is not equal to current dot val. Then what do we do? Immediately return false. Else we add current dot left to the queue and current dot right to the queue if they are not null. And every time we pull an element. So yeah, this is how the code is. And then we have this. So let's run. So let's submit this. Yeah, coming to the time and space complexity, we are storing the nodes in a queue. So let's say at any level, the maximum number of nodes could be in a complete binary tree would be n by 2 if there are n number of nodes. So my space complexity would be big O of n and my time complexity would be big O of n because we are, every node goes into the queue once and comes out of the queue once. So that is the reason why. So yeah, this is it. Yeah, thanks for watching.